we're going to take a look at some specific examples as to how to evaluate limits as x goes towards infinity. So first one we have here, limit as x approaches infinity of the rational function 9 plus 9x plus 4x squared over x squared. All right, so we certainly don't want to plug in infinity because then we would get something like an infinity over infinity. That's not good for right now. So what we're going to do is we're going to do some algebra magic, very similar to what we did in the previous section. And we're going to say lim as x approaches infinity of 9 over x squared plus 9x over x squared plus 4x squared over x squared. So we just use that monomial rule where we just divide everything by x squared. We can simplify the latter two of the expressions, and we're going to end up with lim as x approaches infinity of 9 over x squared plus 9 over x, since there's one x on top and two x's on bottom, that second expression. And then finally just plus 4. Finally, we can go ahead and we can substitute the limit back in. So not sure what happened here. And by substitution, we get 9 over infinity squared plus 9 over infinity plus 4. All right, now, remember that anytime you have infinity in a denominator and the numerator is a constant, those are just going to go to 0. Right? So this is just going to end up being 4. And of course, if you don't trust me or trust my logic, couldn't you also throw this expression into your graphing calculator and see what happens for the long-term behavior of x? In fact, let's do that since it's our first time doing this. So we have, I'm going to go y equals, so we have parenthesis 9 plus 9x plus 4x squared. And we're going to divide that by x squared. It looks like it's just copying a whole bunch of stuff from before. No big deal. I'll get rid of that. So here we go. And we can just do divide x, and the square should be in there. Okay, so sorry about that taking so long. All right, so let's graph it. And we're going to zoom standard. All right, and we get this sort of weird graph. And what I'm going to do is I'm just going to trace it. And we know initially it's like really weird, but what we're really looking at is the y value. And I could just keep clicking on this for a very long time. All right, and notice what happens is, and I could actually just substitute the value. All right, so check this out. I'm going to do second, and I'm going to calc. All right, and I'm just going to go value. And let's enter a really big number, like 999. And we're going to hit enter. It says invalid. All right, maybe it's too big for that. So let's try it again. I think maybe I broke the calculator because the number was too big. So let's try, we're going to graph it, and then we're going to calc. Let's try something like, for the value, let's try something like 50. Maybe it's something the calculator can handle. Still invalid. All right, well, regardless, we know that if we were to just keep tracing the graph of this, eventually we would run into 4. And we can kind of see that there's a horizontal asymptote there. All right, so not sure why the calculator didn't like that. Maybe the number was too big and the calculator crashed. Regardless, that's a way to check it. Now, another problem. Now, this time it's a little bit different because we don't have a monomial. All right, so we have this 20x to the 5th minus 9 over 4x to the 5th minus 5x to the 4th. And what we're looking for is we're looking for both positive and negative infinity values. Now, certainly we can graph it, all right, but let's try to look at the analytic techniques first for this. All right, so what we're going to do first is we're going to go ahead, and this is a technique that you can use all the time. You're going to start, and let's just do letter A as it approaches infinity. You are going to divide everything by the highest power of any exponent in the denominator, which in this case is going to be x to the fifth. Now I'm going to show you a little bit shorter way in a moment, but you would have 20x to the fifth over x to the fifth minus 9 over x to the fifth divided by 4x to the fifth over x to the fifth, and then finally minus 5x to the fourth over x to the fifth. And it looks like we've made this really nasty. And by the way, this is completely legal. All right. What we're going to do is we're going to divide everything out and simplify. So lim as x approaches infinity. Now x to the fifth over x to the fifth cancels, and we're left with 20. We have 9 over x to the fifth. X to the fifth over x to the fifth just becomes 4. And then 5x to the fourth over x to the fifth just becomes 5 over x. Right? And now what happens when we substitute infinity back in? All right, well, we get 20 minus 9 over infinity to the fifth divided by 4 minus 5 over infinity. And what happens when we divide by infinity? It just goes to 0. All right, any constant divided by infinity. So this just winds up being 20 over 4, which is equal to 5. We could do the exact same thing, especially at this step, when we evaluate negative infinity. All right, so for part B, we would just say lim as x approaches negative infinity. And we could just reuse this step because all we did was algebra. We didn't apply the limit at this point. So that would be 20 minus 9 over x to the fifth divided by 4 minus 5 over x. We would substitute negative infinity in here. So that's 20 minus 9 over negative infinity to the fifth divided by 4 minus 5 over negative infinity. And just like we saw before, anytime we either have negative infinity or positive infinity in the denominator and a constant in the numerator, those just go away. We're left with 20 over 4, which is again 5. All right. Of course, if we don't trust the answer, what we can always do is we can just go through and plug it in the calculator. All right. So this will be our last part of this problem. So y equals, I'm going to clear this out. So we have 20 x to the fifth, up to 2 is 5, minus 9. And then we're going to divide that by 4x to the fifth minus, I think it was 5x to the fourth. I'll verify that before we go any further. So 4x to the fifth, 5 minus 5x to the fourth, and then we're going to graph this thing. All right, so we get a really weird graph. Now I'm going to zoom it, and I'm going to zoom standard, and then maybe zoom out just a little bit. So maybe zoom out once. So I'm going to do 3 for zoom out, and hit enter. And you can clearly see that from both the left and the right-hand side, this graph is looking like it's approaching the same value. So let's trace it and see what happens. All right, so if I'm tracing x as it goes towards negative infinity, it looks like the y value is ever so slightly getting larger. And what's it approaching? It looks like it's approaching 5. All right, now I could keep doing this forever, or maybe for at least 30 seconds, and I'd probably get bored with it. All right. What if I wanted to do the other way? All right, so I'm going to zoom standard, then I'm going to zoom in. And it looks like I broke the calculator. Let's see if I can put it out of here. No, broke the calculator. Well, regardless, we remember that from the other side, it looks like it's all going to go through, and it looks like it's going to go towards negative infinity, or towards, excuse me, 5 as well, either from negative infinity or from positive infinity. All right, so that's why this works out. I encourage you guys to always graph when you guys are using, trying to find these infinite limits, so that way you all can see that the limit does approach a specific value. All right, so in the next video, we're just going to take a look at 2 more types of problems with infinite limits, and then we'll be done with those infinite limits.